Let us look at proposition number 66 of book 10 of Euclid's Elements. The proposition says a straight line commensurable in length with a binomial straight line is itself also binomial and the same order. So basically what the proposition is saying is that we have a binomial AB. So if we have another line CD commensurable in length with AB, then CD is also binomial and of the same order. So order basically means that if AB is first binomial, CD is first binomial. If it is second, second, third, third, fourth, fourth, fifth, fifth, sixth, sixth. So let's see how we can prove this. Divide AB, a binomial, into its terms at E with AE greater than BE. Now AE and BE are rational straight lines commensurable in square only. Why? Because it is a binomial. And E is the point at which it has been divided into its terms. So I did bring in CD. So let me draw CD. And now divide CD at F such that AB is to CD as AE is to CF. Okay, so let's do that. So here AB is to CD as AE is to CF. What does that mean? That means the remainders will also be in proportion. BE is to DF as AB is to CD. AE is commensurable with CF and BE with DF because AB is commensurable with CD. And because of this proportionality. So that means CF and DF are also rational. So we can write AE is to CF as BE is to DF. Or alternately, we can say AE is to BE as CF is to DF. Now, CF and DF are also commensurable in square only. Why? Because AE is commensurable with BE in square only. So DF and CF are rational and commensurable in square only. That means CD is binomial. So, this part is pretty straightforward. Let's see how we can show that they are of the same order. So AE square is greater than BE square by the square on a straight line commensurable with E. AE square is greater than BE square by the square on a straight line commensurable with AE. This is one possibility with respect to this binomial AB. Or the other possibility is that AE square is greater than BE square by the square on a straight line incommensurable with AE. So these are the two possibilities. Okay. Now let's take the first case. If AE square is greater than BE square by the square on a straight line commensurable with AE, then CF square is also greater than DF square by the square on a straight line commensurable with CF. If that is the case, then we get into conditions because we have not been given any additional information as far as the binomial AB is concerned. If AE is commensurable with a rational line set out, then CF is commensurable with it because AE is commensurable with CF. So if AE is commensurable with a rational line set out, then CF will also be commensurable with it, which implies that AB and CD are first binomial straight lines. If B is commensurable with a rational line set out, then DF is commensurable with it, which implies that AB and CD are second binomial straight lines. And if neither of them, that is AEB, is commensurable with a rational line set out, then neither CF and DF is commensurable with it, which means AB and CD are third binomial straight lines. Remember, all this is if a square is greater than b square by the square on a straight line commensurable with a. Let's look at the second case. If a square is greater than b square by the square on a straight line incommensurable with a, then CF square is greater than DF square by the square on a straight line incommensurable with CF. So again, we end up with conditions. If A is commensurable with a rational line set out, then CF is also commensurable with it, which means AB and CD are fourth binomial straight lines. If B is commensurable with a rational line set out, then DF is commensurable with it. That means AB and CD are fifth binomial straight lines. If neither of them, A and B, is commensurable with a rational line set out, then neither CF and DF is commensurable with it, which means AB and CD are sixth binomial straight lines. So we have shown that if a straight line CD is commensurable with a binomial straight line AB, then CD is also a binomial, and the same time it is of the same order as that of AB. So that was proposition number 66 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.